Hey, welcome back to the course. So in the previous lecture, we have implemented this function, isn't it? It's bootloader jump to user application, and we tested it successfully. And in this lecture, we will implement bootloader UART read data. So this function will be executed whenever you press the user button while powering up of the board, isn't it? So this is the function in which the bootloader reads commands sent by the host. So now let's see how we can implement this function. So I have just implemented this function over here, just below the main function here. And it consists of some code. I will explain that line by line, don't worry. So first of all, I have declared one global variable, that is BLRX buffer. So it's an array of 200 bytes. So let's see where it is defined. So I'll just go to its declaration. So in the global space, I have just declared uint 80 BLRX buffer of 200 length. So here we will accumulate all the command bytes sent by the host for the bootloader, right? And I have just written some comments for you. Here we will read and decode the commands coming from host, that's okay. And we read in this way. First read only 1 byte from the host. That 1 byte is actually length field of the command packet. So once bootloader reads that 1 byte, that is actually length to follow, then bootloader will come to know how many remaining bytes it has to read. So that's why we read twice. So first we read only 1 byte, all right, into the RX buffer, and that is actually the receive length or length to follow. Okay, and after that, by using this data, we read all the remaining bytes of the command packet. So how does a command packet look like? For example, let's go to our PPT. So here it is. This is a command format for BL get version, that is bootloader get version. In every command packet, the first byte is length to follow, isn't it? So this we have already discussed. So that's why the bootloader first reads this byte first, and after that bootloader comes to know how many remaining bytes it has to read. So that's what's happening here. And after that, the second byte is always the command code, isn't it? So we use the switch statement in order to decode that command code, and based on that we process different commands coming from the host. And this HAL UART receive is an API from the UART driver of the ST in order to receive data from the UART peripheral. Here the first parameter is CUART, so which is nothing but our command UART. Alright, so that is actually defined to address of the second UART handle. So this is the UART handle for the UART2, and this is the UART handle variable for the UART3. So and this is the buffer where we keep all the received bytes, and this is the length field, and this is the delay field for the driver in order to wait for the execution of this API. Now let's implement this switch case. So here we decode the command received. So we know that all these are our supported commands, so we have to decode which command it is. So for that I have a piece of code. I'll just paste that. That is very simple to understand. Here it is. So these are the case statements in order to decode the command which is received in this field. So if it is BL get version command, then we will call this function in order to handle that command. And if it is BL get help, then we use this function in order to handle that command, and we pass the buffer as an argument to all those helper functions which are used to handle those commands. And if this value, if it doesn't match to any of these commands, then we will simply print command code received from the host is invalid. So now where these macros are defined. So these macros we have to define in the main.h. So let's do that. Okay, so let's go to main.h and we will hash define all those commands as C macros. Alright, so now let's convert all these commands into C macros in the main.h. So let me go to main.h and I will do here. So these are the bootloader commands which we need to implement in this project. So the BL get version, that is this one, has the command code 51. So I just hash define to 51, and for get help it is 52. Alright, so and I repeat it for all the supported commands. So the command code starts at 51 and ends at 0x5b. Alright, so now our next job is to implement all these individual handle functions which handle a particular command, isn't it? But before that, we will first write the function prototypes of all these helper functions in the main.h. So for that, I'll just copy this and I'll go to the main.h, and here bootloader function prototypes, just paste that function. Let's say this is void and the argument type is uint 8_t star, isn't it? Right, so this is the function prototype for the get version command handle function, and we have to repeat the same thing for all the handle functions. So let's do that. Alright, so now I added the function prototype of all the individual handle functions. Alright, so now if you compile this code, you will get this error. Okay, uint 8_t is undefined. That's because in the main.h we have used this shorthand notation of data type, and we have not included any supportive header file for that, isn't it? So that's why you will get this undefined error. Let's resolve this error. Okay, so I'll just go to code blocks. Let's go to main.h, and here let's include stdin.h. all right, great. And in the main.c we have main.h and stm32f4x6hal.h. actually the user defined include files has to be after the standard library header files, so that's a good practice always. All right, so let's remove from here and let's include after the standard library include files in the main.c. Great, so now let's go to our kill and let's compile. So it's compiling. Alright, so now we got all these undefined symbol errors. That's because we are calling all these handle functions, but we have not implemented them in our code, isn't it? So that is our next job, and I will cover that in the next lecture.